Congratulations, everybody. We have entered geometry. We are done with algebra, pre-algebra, algebra. Graphs and functions were part of algebra anyways, but we are done with that, and we're moving on to geometry. Now, before we get into the nitty-gritty of geometry, which would be the shapes and all this and measurements and all of that, there's this transitional period. There is this lesson, the Pythagorean Theorem, which incorporates algebra, specifically multi-step equation, and solving. But it's also including shape. So it's like that transitional lesson, and then it goes straight into area and perimeter and all that stuff. But this one's going to be pretty straightforward because it is sort of a continuation of algebra, even though it is considered geometry. So the first thing we're going to do is Pythagorean Theorem. Now, I have the GED formula sheet here because from this point forward in the geometry section, this is going to be your holy Bible. This right here is like where the rest of the formulas in that sheet comes into play. If we were to zoom in, we would see we have this little thing called the Pythagorean Theorem. So, and of course it's under the algebra section, even though we are in geometry right now. So that's a formula. A squared plus B squared equals C squared. You guys have probably heard of it. If you haven't, totally fine. That's what the lesson is for. We're going to learn what's the purpose of this formula and how to use it. And we're going to go from there. So the purpose of the Pythagorean Theorem, aka the A squared plus B squared equals C squared. It is a formula used to find the missing side of a right triangle. So if I were to draw a triangle, if you were to think of a triangle, you would probably think of this, right? And you're right, this is a triangle. A right triangle is a specific type of triangle. It's a very, very common triangle. It is a triangle that happens to have, if you notice, let me make this one a little better. If you notice, it has a corner piece with two straight lines making that corner piece, right? So if you look here, if you look at each corner of this triangle, it's not a perfect 90-degree angle. That 90-degree angle is what makes a perfect corner. This is a 90-degree angle. If you could make a little box in the corner, that tells you it's a right triangle. It's a 90-degree angle corner. And that is what's the difference between a right triangle and just a standard old triangle, right? In construction, they use the Pythagorean Theorem a lot because of roofs, right? If you were to make another right triangle, doesn't that look like a roof right there? Yes. And that's how they get the slope and this and that. We're not going to dive into that. But just know that we're going to be dealing with right triangles. What is a right triangle? It is a triangle that happens to have a perfect 90-degree angle. What is the purpose of the Pythagorean Theorem? The formula? The purpose of it is to find the missing side of a right triangle. So that's what we're going to be doing today, is finding the missing side and finding the missing measurement. So if we were to look at this right triangle, and if I were to put, let's say 4, 5, and then x, we will have to use the Pythagorean Theorem here in order to find what x is. We got to find the missing measurement. This 4 could represent inches, feet, it doesn't matter. Let's just say inches for now. And this bottom measurement is 5 inches. And we need to find how much inches it is from here to there, right? So how do we do that? How do we use the Pythagorean Theorem? Well, we need to first know what A, B, and C is in terms of a right triangle. In a right triangle, and it doesn't matter what direction they flip it on you, which I'll show you in a sec, what you need to know is that the sides that connect to make that 90-degree angle, that is your side A and B, and it doesn't matter which one it is. I like to think of the bottom one as B just for base, kind of, right? But it technically doesn't matter. This side could be A, this side could be B, or vice versa. This side could be your B and this side could be your A. It does not matter. What really matters is the long part of a right triangle. You need to know that that long part is always going to be your C, okay? It has a nickname. It is called the hypotenuse. I'm not even going to attempt to spell it, but you need to know that the long part of a right triangle, the part that isn't connected to that 90-degree angle, that is called the hypotenuse. So if they ever give you this right here and they say something like, what is the measurement of the hypotenuse? Don't be like, what did they just ask me? All they're saying is, yo, what is the measurement of the long part of the right triangle? Or what is the measurement of C, right? So we know what our A is, we know what our B is, we know what our C is. This is algebra right here, right? Let's just fill our formula in with the numbers. We know A squared plus B squared equals C squared. So I'm going to get my A. What's my A? I'm going to say 4 squared plus B squared, which equals B is 5, equals my C squared. And that's exactly what we want to look for. We want to look for our C, right? So what's 4 squared? Well, you could take out your calculator. 4 squared. You should memorize these, right? You should memorize your square roots and your squares and all that, at least the basics up until 10, but it's fine if you don't. You could just have 4 squared. It'll tell you the answer, 16. Plus, what is 5 squared? Same thing. You just come here. You should know it's 25, but if you didn't, you could just 5 square it and then get to 25. 25 equals my C squared. And then you solve it. 16 plus 25. Again, if you don't know it, it's totally fine. Plus 16, 25 plus 16. That gives you your 41. Always take out the calculator. And now you have your C squared. But here's the thing. It doesn't make sense to say that if this is 4 inches and this is 5 inches, this is 41 inches. That kind of doesn't make sense. You kind of look at it. What's the thing that's wrong? I don't know if you notice. I did say this in a couple videos back. Long couple of videos back. You are never done when you find the variable. And do you remember when I said when you find the variable and you have something like this, you aren't done because your variable must always be positive? Do you remember that? The same thing is true in this case. You are not done until your variable is not only positive, but you're not done until your variable is just the variable, when it's just C, no squared, no nothing. So before, how do we get rid of the negative? We would divide by that -1, that invisible -1, right? How do we get rid of the squared? It's by doing the square root of whatever your answer is. When you do the square root of 41, you come here, second square root 41, enter, gives you that. You convert it, 6.403, let's just say it's 6.4, right? And that is your root, not your variable. That is the actual C. You're not looking for C squared, you're looking for C, which is the only way to get that is whatever answer you get here. Once you add your A squared and your B squared, you need to square root it, and that gives you your C, and that makes a lot more sense. It makes sense that this side would be 4, this side would be 5 inches, and this side, which is the longer part, should always be bigger than those numbers. It should be 6.4 inches. That is how you find the missing side of specifically the hypotenuse of a right triangle. Just using basic old formula, the Pythagorean Theorem formula, and using your skills of multi-step equations. Where do things get tough is, well, when they give you the C, but they ask you to find the A or B. So let's look at this example right here. It's kind of weird, but the other reason why I'm going over this example, even though it's kind of pixelated, is because they're not always going to give you just a solid shape. They might give you, like in this case, a real world scenario. They might give you a brick, a ladder, and then the measurements of where the ladder is to the floor and the distance from the floor and this and that. And they might ask you, what is the size of the brick wall? How tall is the brick wall? It's up to you to identify that this is a right triangle, right? It's just seen in the real world. And if it helps, just rewrite it like this. We know this is 3 and we know this is 13, and what they want us to find is the brick wall height. So what do we do here? Well, if we use our Pythagorean theorem A squared plus B squared equals C squared. We know we don't know what A is, but we know what B is, B squared, and we know what our C is because they gave it to us in this specific example. So what do we do here? Well, we solve what we can. We don't know that, but we know 3 squared is 9, and we know 13 squared is, again, always take out the calculator, 169. How would I do to leave A squared by itself? You guys should know this. You should be on top of this. Go back to the algebra section. Go back to multi-step equations. What do we do to solve for A squared? We minus the 9 on both sides, and that's what leaves A squared by itself, giving us 160. Are we done? No. A is not by itself. I want to find that root, that root A, right? So we square root 160. Oh, we get a weird one. You just convert. Always convert. You're going to do a lot of conversions here. And what was the answer? 12.65, let's say. 12.65. If you don't know how I'm rounding, go all the way back to the beginning of the module of math and look up how to round. And just practice your rounding because the worksheet is going to tell you what to round to. So you got to make sure you round to the correct round value. So it makes sense, 12.65. It makes sense, 12.65. As long as it's less than the C, you should be solid. That is how you find the A or B when given the C. All right, so just the other note, I'm not going to do another example that you pretty much know what to do now, but just be aware that if they give you this right here, don't be surprised if this is a right triangle right here. Let's say I were to twist it and put it like this. Your brain might not really realize that this is a right triangle. You might look at this and be like, this is a weird triangle, right? But you should know there is the 90-degree angle. And this is how the GED is going to trip you up. They're going to give you the measurements. They're not going to give you the right triangle side, but they're going to give you the measurements of, let's say, 3, 4, and then they ask for that. And then in your brain, you're just like, what is this? It's up to you to twist that head and see, oh, snap, it's a right triangle, and I got to use Pathagorean Theorem to find the hypotenuse. So just be aware of that, okay, my friends? Not always going to be looking so nice. And just like in this example, be aware of real-world scenarios. Like in this case, you didn't be given a right triangle, but you should eye that it is a right triangle. And they could give you multiple versions of that. They might give you the famous tree that makes a shadow. You put a string to the top of the tree from the end of the shadow. They give you some measurements like 5 and 6, and they want to know how long of a string you need. That's just another example. They could give you a very common one. Building there. Your house is here. The library is here. And they give you a real world scenario of you always go from your house to the library, then from the library to your work. From your house to the library, it's 20 miles. From the library to the work, it's 10 miles. You decide to take a shortcut. You go from your house straight to your work one day. How many miles did you walk? It's up to you to see that this is a right triangle, okay? So those are the real world scenarios that you're going to be given, real world questions that will be given. But as long as you know the math, as long as you can see that it's a right triangle, as long as you can determine you got to use the Pythagorean theorem to help you, it'll all be a piece of cake, my friends. So please ask for any help. If you come across any anomalies, please let me know, message me, and I'll make sure to help you all out.